Bright QT. Every student matters.
Hello students, and in this topic we will be studying about transfer of charge. Till now we know that charges are two kinds of nature, right? Positive and negative. Till now we studied that charges are static, right? They do not move. When they move, we call it as electric current, right? Now for studying the transfer of charge, firstly we have to understand a simple electroscope. This will make it clear that charges can be transferred, right? So let us start. This simple electroscope consists of a glass jar, right? It has a cork. It has two aluminium foils, basically aluminium foil folded in the middle. This is the aluminium foil and you have folded it from the middle, right? Two aluminium, basically this is only one but it is looking like two. You have folded it and hung it on an opened paper clip. You know, paper clip is made up of a metal and it is this like this in shape, right? To hold the paper, this is the paper clip, and when you open it, it looks like a wire, right? So this is the wire that you have used. So what do you have to do? You have to charge a comb, right? You take a comb and you charge it by rubbing it with your hair. Now you bring this charged comb near this end of the electroscope, near this wire. You touch it with this wire, right? After some time, you will see that these aluminium foils start repelling each other. They will become far away. Earlier they were in this position and then they will repel each other and there will be a larger gap between them. As you can see, this gap will increase. They will repel. Now what does this tell you? That this comb that was brought here carried a charge which travelled through the wire to the aluminium foils, and because this is one kind of charge, both the aluminium foils acquired positive charges, right? And because they have acquired the same kind of charge, they started repelling each other, right? They started to repel each other. This is because the same kind of charge was acquired by both of them. So what does this experiment tell you? Basically, a simple electroscope helps us in understanding that a charge can be transferred from one body to another. As this apparatus was not charged, right? We brought a charged comb near this end so that the charge would flow down the wire and reach the aluminium foils. So this experiment tells us that charge can be flown from one place to another. The aluminium foil strips receive the same charge from the charged refill through a paper clip. This basically is a comb. I utilized a comb in the experiment. You can say refill as well. The aluminium foils, which are present in the bottom, receive the same charge, right? There is only one kind of charge that the refill or comb can carry. So receive the same charge from the charged refill through the paper clip, right? This is the paper clip, that wire basically. Then the strips carrying similar charges repel each other and they become wide open. These foils repel each other and they become wide open. Such a device, which can be used to test whether an object is carrying a charge or not, is known as electroscope. Now students, as you know, if the comb was not charged, so there wouldn't have been any charged flow of discharge, right? Flow of charge. Then the aluminium foils would not be repelling each other. If the comb was not charged, there will be no repulsion between aluminium foils. But whenever you bring a charged body near that paper clip, the aluminium foils will show some repulsion. This is why electroscope can help us in understanding whether a body is charged or not, right? With the help of an electroscope, we can find out whether a body is charged or not. Now there is another kind of electroscope, somewhat better electroscope. This is a gold leaf electroscope. It has a brass disc, an insulator plug instead of the cork, right? This brass disc, and then it is connected to a brass rod. In the earlier experiment in the simple electroscope, we used a paper clip, right? Then this is a glass bottle. This is a metal foil, and this is used for earthing, to send the extra charge into the earth with the help of this metal foil, right? And instead of aluminium foils, we have gold leaves. Now this electroscope works very similarly, but it can also help us in knowing what kind of charge is flowing, what kind of charge is present, and what is the amount of charge flowing. Right? These are the two extra things that this electroscope can tell us. Firstly, the kind of charge, positive or negative, it can tell us, and the amount of charge flowing. You do not have to understand the details of it, you just have to know the benefits of a gold leaf electroscope, right? Now you know how an electroscope works. You bring a charged body here, the charge flows down the paper clip or brass rod, and the aluminium foils or gold leaves show repulsion whenever there is a charged body, right? So this was electroscope. Now coming to earthing. As you saw that here, this apparatus was used for earthing. The metal foil connected at the bottom of the glass jar is being utilized for earthing. Let us see what earthing is. The foil strips collapse as soon as you touch the paper clip with hand, right? Basically, if we are talking about the simple electroscope, there was a paper clip extended outside the glass jar where we touched the comb. But if instead of the comb you touch your hand, the foils collapse. They do not repel each other anymore because the charge has been removed. Why is that so? The reason is that the foil strips lose charge to the earth through your body. That charge that was present inside the apparatus has been now caught by your hand, and it flows through your body and moves into the earth, right? The foil strips are discharged. Now the process of transferring charge from a charged body to the earth is called earthing. Basically, when we touched the paper clip, the charge flew through our body and went into the earth. This process is earthing. The definition being the process of transferring of charge from a charged object to the earth is called earthing, right? And in this topic we will be studying about the story of lightning, right? Till now we have understood the production of charges by rubbing, the transfer of charge, and we have a brief introduction of lightning as well. Now that we know that how charges are produced and transferred, we can understand the story of lightning, right? So students, first of all, you have to understand that when there are clouds present, due to water and dust particles, due to their presence, there occurs rubbing between the clouds. Rubbing is already happening, but due to water and dust particles, charges are produced, right? And it is believed that the higher clouds are possessing the positive charge, they acquire the positive charge, and the lower clouds, they acquire the negative charge, right? Now when there is rubbing between these clouds, there is lightning produced in the air itself, right? Because the sparks are produced between the clouds. But when, as you can see here, there is a spark produced. It is also assumed that the points on earth such as high poles, trees, possess the positive charges. The land possesses the positive charges. So there is an electric discharge from the clouds to these heighted points, and this ultimately causes lightning on earth. The electric discharge from clouds to the earth is basically due to the charge difference between the lower clouds and the land, and due to this charge difference, This charge flows from the lower clouds towards the earth, causing the lightning on the surface of earth, right? So this was the basic story, students. So such rapid flow of charge through the air between two oppositely high charged cloud is called as electric discharge, right? Let us read again. Such rapid flow, rapid means very fast flow, of charge through the air between two oppositely high charged clouds is called electric discharge. It can also happen between clouds and the land, right? This is also known as lightning. This is also known as lightning, right? Now let us see a few facts related to lightning. Lightning needs a direct, easy path to enter the ground. It needs a direct, easy path. It cannot just hit the earth. It needs a path. Such path is provided by tall objects like trees, poles, buildings, then lone buildings and wooden barns, and water, because water is a very good conductor of current. So either it requires high posts, right? Lone buildings, wooden barns, or water. During a lightning strike, about 10 to 20,000 amperes of current flows. 10,000 to 20,000 of amperes of current. Imagine this is the magnitude of the current flowing. This is very, very high. This can cause deaths of people, and it causes deaths of people and collapse of trees and etc. So this is a very huge magnitude. The air in the path of the lightning gets hotter than the surface of the sun. The heat and light produced are very much, too much of energy is produced due to high charge. It gets to about 30,000 degrees Celsius. This is the temperature of the air through which lightning is passing. So this is the amount of energy flowing, 10 to 20,000 amperes of current, and the heat is so much that the air that is in between the lightning's path, it becomes hotter than the surface of the sun, and the temperature amounts to about 30,000 degrees Celsius, right? Lightning safety. Students, till now you have understood that how lightning is produced, how dangerous it is. It is basically a destructive phenomenon, right? So now we have to understand that how can we secure ourselves if lightning is happening, right? We need to understand that as well. The first thing that you do is rush to a safer place. You should always look for a safer place and you should rush there. Now, what is a safe place? A safe place can be considered as a house or a building. These two things are considered as safer places, right? You should always rush towards a house or a building, and you should turn off electric equipments, right? You should stay away from water, and you should not call anyone from landline phones. Basically, anything that uses wires should not be utilized during the lightning, because electric equipments can carry that charge and you can catch lightning, right? Now, if you're traveling by a car or by bus, you are safe inside with windows and doors of the vehicle shut. You should shut all the windows and doors of the vehicle if you are in a car or in a bus, right? Now, do's and don'ts during a thunderstorm. Firstly, if you're outside, you should not stand straight, right? Never stand near a pole or a tree. Never stand in anything near, stand under a pole or a tree or anything that has a good height. You should not also go to the terrace of your building, right? You should always stay at the ground floor possibly. And if you are outside, there is no building near you, there is no car or bus, you should sit like this in a squat position. We call it as thunderstorm squat. You should squat down and cover your ears and put your head down as well, so that you will never be able to catch an electric current due to the lightning, right? This is one of the things to do. If you are inside, it is not wise to call up a person who is receiving your phone through a wired phone. Basically, using landlines is strictly prohibited during lightning, because this may cause catching a lightning. This may conduct the charge flowing in the air, right? Bathing should be avoided during thunderstorms to avoid contact with running water. The running water also may be carrying a charge. So you should never take bath during a lightning, because the running water may be carrying charge. Now, electrical appliances like computers, TVs, etc. should be unplugged. Electrical lights can remain on. Electrical devices like computers, TVs, etc. should be unplugged. Lights can only remain on, right? And now coming to lightning conductors. Students, lightning conductors are used for earthing. This is a lightning conductor, as you can see in the second picture. This is the lightning conductor. It looks like this. It is basically made such to catch the charge, right? Whenever there is a chance of lightning, this rod helps very much. What happens exactly? You put here the lightning rod, right? Lightning conductors are those substances basically which catch the lightning. Right? So this is used to catch the lightning if it is approaching the house. You fix the lightning rod on the top of the house. Then it is connected with a wire, with a conducting wire that flows besides the house into the earth, right? This is another glass rod which is fixed, ground rod basically, which is fixed inside the ground. This lightning rod attracts the current from the air and it sends the current through the wire to the earth without disturbing the house, keeping the house safe, right? So as to save yourselves from the charge flowing through the air, this lightning conductor is used, lightning rod basically. It catches the spark, and then through the wire it sends the current into the earth, right? So this is basically used for earthing. We have already studied what earthing is, right? So these are lightning conductors and they are very useful.